What is going on, you guys, and welcome to another video. And today is going to be a fun one. We are going to be upgrading the sound system completely in my 370Z. I've already picked out everything I need here, from the speakers to the amplifier. So we will be doing all of that today, and I'll be showing you guys how to install a sound system in your car, as well as how to pick out a proper amplifier, speakers, and so on. We just got finished in the previous video creating the subwoofer box, which we are going to fit inside the spare tire, but we'll get to that a little bit later. We'll go ahead and get started with this video, you guys, and it will be a pretty long one, so do be patient with me. I am trying to explain in great detail how to pick out everything that you need for your sound system, as well as how to install it properly. But the idea here is that even a beginner that has never ever installed a sound system like myself will be able to follow this and be able to upgrade their car to sound a lot better. So before we get started, I guess we'll go ahead and go into what all exactly I have here. So to start with, we of course have the amplifier that we are going to need to be able to run all of the new speakers. This will be a Bluetooth setup. I have a Bluetooth adapter here, which we will be using so that way you can hook up your phone to it. That will drive the amplifier, which will in turn drive, of course, all of the speakers. As far as speakers go, we do have basically a bunch of Pioneer units here. Here is the Pioneer woofer and tweeters that I will be using. This woofer came with, it looks like, an adapter here to install it in the door properly. For the sub, you guys may have seen this already, but I do have a little 8-inch sub picked out here. Nothing major. I'm not trying to go for stupid amounts of bass. Just a little 8-inch sub should be able enough to give this a little bit of kick. We've got a fuse here, which we will need to install for the amplifier to prevent it from overheating or anything. And then of course we've got tons of wire which we will need to be able to run throughout the car, and then just some cable management stuff and a couple of RCA adapters and connectors here. So again, I will leave a description of each of these down below, so that way if you guys want to just copy my setup, you can go ahead and just pick this up. Also understand, guys, that I am not a professional audio engineer. I do not accept responsibility if you guys do damage your car in the process of installing this. Just be careful when you guys are doing this, and let's go ahead and get started. So the first step in this install video is going to be finding a location to mount our amplifier. So I figured I'd go ahead and explain to you guys how to go about choosing a proper amplifier for your particular build. Now, normally I would actually say go ahead and find your speakers first and then choose an amplifier to match, because ultimately your speakers are going to determine how much power your amplifier is going to end up needing, as well as the configuration that you're looking for. Are you just going to be running off of your stock speakers? If that's the case and you're just upgrading your stereo, you probably don't need an amplifier. Your stereo is going to be able to power it just fine. But if you're trying to add a subwoofer, or you're looking to replace your stereo with a tablet, you're going to need an amplifier to run the speakers that you have. Perhaps you're trying to get a little more volume out of your OEM speakers, and you're going to be installing some speakers that are rated at a higher power. All of these things means that we need an amplifier. An amplifier, basically what it does is it takes the input signal, the sound signal from your stock stereo or whatever it is that is playing the music, and it's going to be able to amplify the sound to the levels that you're going to need to run your speakers. So some considerations that you need to make when choosing an amplifier: you need to find an amplifier that can provide the correct amount of power, both RMS as well as peak power. RMS power basically is the average power that the amplifier can put out, or that the speaker can take if you're looking at specifications for speakers. Whenever you're playing a sound, you may have something like a sine wave, which is like a representative of the voltage that's being applied to the speaker. And if you were to take the square of that, you'll get a basically absolute value curve of it. And then the RMS is the average of whatever that voltage is, which in turn relates to power. You can determine the total RMS power that you're going to need based off of the total RMS power of each of the speakers added together. If I had maybe 4 20-watt speakers, I need a total of 80 watts of RMS power to be able to drive all 4 of them. You also need to consider your peak power to be able to amplify your sound enough to be able to hit those peaks in the song. Whenever your speakers are maybe rated for a peak power of, in this case, let's say maybe 30 or 40 watts, if each of them are rated for 40 watts of peak power, you might want to look for an amplifier that can make sure it provides that total peak power to the speakers. 40 times 4 gives us 160 watts of peak power. It's important to consider both of these things. You want to make sure that your amplifier can provide enough power on average to constantly keep the speakers going, but you also want to make sure that it can provide enough peak power to be able to run them when the song is really hitting hard. The next important consideration that you need to make is how many channels are you going to need based on the configuration that you're looking for. So I have a couple of common configurations here. Some cars may only have 4 speakers. It might have 2 in the front, 2 in the back. but both the left and right side of the speakers in the car may be kind of connected together. So here we have the 4 speakers, and the 2 on the left and the 2 on the right are both connected in a common channel. What this means is you can control the left and the right side, you can control the balance, but you can't control the fade from front to back. Maybe that's not important for you, but in this case you need something like a 2-channel amplifier to be able to power the left side and the right side as separate channels. In the case of my car, I'm going to have 2 front speakers, a tweeter and a woofer, on both sides, left and right. These are both connected together. You can't really tune them independently. So those represent 2 channels, but I am also looking at adding a subwoofer. That's the main reason for this build. So in order to add the sub, it's going to run off of its own channel. So therefore, I'm going to need at least 3 channels for my amplifier. Sometimes you might have a car that has 4 speakers and you can control them individually. That way you can change the amount of fade, how much the sound comes from the front and the back. For this, you'll need a 4-channel amplifier. And if you wanted to add a subwoofer to that type of configuration, then you would need a total of 5 channels. These are the common channel counts that you'll see with most amplifiers, but there are more out there. You do have 1-channel amps that are meant just to run a sub. You may have amplifiers that have more channels, but for the most part, what most people do is they'll go for one of these sort of setups. So it really all just kind of depends on what you're looking for in your car and how many speakers you plan to put in your vehicle. Another consideration is going to be the channel configurations. Basically, can you, for instance, bridge 2 channels into one to be able to drive a subwoofer? You also want to look at how the power is distributed between each of the channels. A lot of amplifiers may have evenly distributed power, so you can do up to 50 watts maybe on each channel. Or it's possible that one channel might be specifically meant for driving a subwoofer. So this is something that you have to look into. You also want to look into the tunability of the amplifier itself. Does it have low pass and high pass filters? For subwoofers, when you don't really care about all of the high end frequencies, you want to make sure that you can filter those out and with a low pass filter, so that way you can send only the low end bass tones to your sub. You also want to make sure that you can tune the amount of, maybe for instance, bass if you're really looking for some heavy bass. You just want to make sure that you can adjust the sound for each of the speakers accordingly. Also important is going to be the size. Do you have a small car and you're trying to fit a small amplifier and try and conceal it? Or, do you not care as much? Maybe you're in a truck and you have a lot of space. So size is something important. If you're a stickler for brands, maybe you'll go for a certain brand. Personally, I wanted to keep everything Pioneer, so that was kind of one of my considerations. And then, of course, we come down to the price point. It all comes down to how much are you willing to spend on your amps. Alright, so I've shown you some of the considerations that you need to make when choosing an amplifier. Now I'll walk you through the process of how I found the amplifier that was going to be right for my build. So the first thing I knew is that I was going to need about a total of 5 speakers. I wanted a tweeter and a woofer for each side to replace the OEM parts, and then I also wanted to install a subwoofer. So that's a total of 5 different speakers that I was going to need to power. I had the 1/8-inch sub, I had 2 of the woofers here, and I also had my 2 tweeters completely picked out. And here is the list of the different power consumptions based on RMS as well as peak. And those numbers are going to be important for determining how much power we need in our amplifier. If you were to add all the totals together, looking at the RMS values, 150 watts plus 2 times 35 for the 2 different speakers for the woofers, and plus 2 times 40 for the tweeters gives us a total of 300 watts of RMS power that I knew that our amplifier was going to have to provide. And then looking at the peak values, 600 plus 2 times 300 plus 2 times 120 gave me a total power requirement of 1440 watts peak. So that was the first bit of information that I needed, and then I knew that I was going to configure it in a 3-channel configuration. I was going to have the woofer and the tweeter on one channel for the left side, the other one for the right side, so that's 2. And then I was going to have the woofer on a 3rd channel and run that independently. But with this, I knew that I had 2 options. I could either look for a 3-channel amplifier that had a more powerful channel just to drive the sub, or I could look for a 4-channel amplifier as long as it was bridgeable. You can bridge channels if the amplifier allows it, to where you can connect 2 channels to form one that has a much higher drive strength to be able to drive like a subwoofer, for instance. Knowing this information, I set about trying to find a speaker, and since I'd already chosen all Pioneer stuff, I decided to go ahead and stick with that brand. And so I went onto Pioneer's website, kind of threw in some of the different things I was looking for. I also knew that I didn't want to spend more than $200. And then I came across the Pioneer GM D8704. So that's the amplifier that I ended up going with. It's a 4-channel amplifier. It's bridgeable, which meets the requirement for the subwoofer. and it's able to provide a total of 1200 watts peak, which doesn't quite meet the 1440 that I was looking for. But I also knew that I was going to be being fairly conservative on the amount of drive that I was going to send to these speakers, because I didn't really want to burst my eardrums and drive it at max. But it was also able to provide a total of 150 watts RMS to each individual channel for the front speakers. So if we were to look at this, we're pairing one woofer with a tweeter. So if we were to add 35 watts and 40 watts together for one of each speaker, that's a total of 75 would be required for that channel. So we're already providing more than double what we need. So that's good for the front channels. And then since I'm bridging these two, based on the ohmic load of the Pioneer subwoofer that I chose, and looking at the data sheet for this amplifier, it's able to provide 300 watts total if it's bridged. So that meets the requirement for our woofer. It needs 150 watts RMS. And this is actually kind of convenient because we only need 75 watts for each of these channels. This is twice as much as what we really need, and it's also twice as much as what we need for the subwoofer. And I bring that up because it means it's fairly balanced. You don't need to overdrive one channel or the other. We're going to be putting them up to about half of their total drive strength to be able to meet the power requirements that we're looking for. So when choosing your amplifier, you will need to go through a similar process. It's all going to depend, of course, on what it is you're trying to do with your build. But now that we have an amplifier chosen, let's get to finding a location for it and let's get it installed. The mounting location of your amplifier is going to be one of the important decisions you'll have to make early on during the install process. You want to select a location that's central to the car if possible to try and minimize the amount of wiring that you'll need to end up doing. You'll also want to consider, do you need to have your amplifier concealed? Do you not want people seeing it? Or do you want to have easy access to it in case you need to adjust it? These are just a couple of things you want to look for. You also want to make sure, of course, that the amplifier fits in the space that you're providing. Alright, so I spent quite a lot of time trying to find a good location for the amplifier over there, and unfortunately it is a little bit too big. I was hoping to try and put it back in here, and while it does sort of fit, it's not going to lay perfectly flat, and there's just a lot of obstructions in the way for being able to mount this. So I think this location is out. So instead, what I am contemplating on doing is going ahead and just installing it behind the passenger seat here. There's a little shelf, if y'all can see. I can mount it up against this piece of plastic here, and the amplifier should fit. I've already checked it. So to make installing this easier, and indeed with pretty much any sound system you're going to be installing in your car, you may want to go ahead and just remove your seats. Fortunately, in the 370Z, I believe all it is just 4 bolts. There are 2 here on the front that are covered by caps. You'll undo those. You'll also undo a wiring harness, which is going to be underneath the seat here. So before we do that, though, we are going to go ahead and unplug the negative terminal, which we will have to do anyways in this car, and then we'll go ahead and remove those seats and see about trying to position our amplifier. Anytime you are messing with your car's electrical system, whether it be running wires or unplugging things, you want to make sure you disconnect the battery so you don't accidentally short anything, which could cause a problem. As a recommendation, when you are trying to remove the seats, you'd probably want to go ahead and remove the bolts holding the seat down first. That way you can tilt the seat back and it makes getting to the electrical wires underneath just a little bit easier. For the 370Z, I think there's a total of 3 wiring harnesses that you have to disconnect, after which you can just go ahead and pull the seat out. Alright, so both the driver and the passenger seats are now completely removed from the vehicle. This, by the way, is much easier to do if you take the headrests off to be able to get it underneath the roof here. You do want to be careful when you're pulling these out. Try to avoid scratching the vehicle with the metal bits of frame that are on the bottom of the seat. But it's just 4 bolts, like I said, and then there's the wiring harness here, which is actually held up by 2 clips. There's a zip tie that holds it somewhere around here on the harness. And then there is another clip that holds it on to the back of the seat. Just cut those 2 plastic clips off and you should be fine. Here is where we are planning on actually mounting the amplifier. Probably just going to screw this into the plastic piece of trim there. But before we can do any of that, I want to go ahead and probably remove some of the bits of trim here on the side of the car. I have already created a video on how to remove these panels here. But we're going to want to take these out because we're probably going to be running our wires through here. So we'll go ahead and take these panels out and then we should be able to start mounting things up. I won't detail how to remove all of these panels in this video. Instead, there will be a link at the top of the screen now, which should direct you to another video that I've done showing how to remove these panels in a 370Z. If you drive another vehicle, you'll need to refer to your factory service manual to be able to determine how to remove each of these panels in your vehicle. Alright, so we've got the side panels removed here. The next thing I'm probably going to have to do, we're going to probably remove the center console that sits between the seats, as well as probably pop off this piece as well as this to try and make running wires easier, and we need to pull this piece off anyway so that way we can mount the amplifier. I'm also going to be running probably my Bluetooth adapter and RCA cables from inside the center console here, where I can get USB power from the port that's in here. So we're going to need to pull this up and then probably end up drilling holes to run cables. So we'll go ahead and do that now. I actually have never really taken this apart. I imagine the first thing we're probably going to need to do is pop this piece out, which I believe you're able to just kind of pull up on. I'm going to go ahead and get a, actually there we go. That's that up now. And then I actually have a bunch of these jumpers under here for whenever I want to add any additional functions like a switch or anything. This wire is actually for the third brake light to be able to turn off the blinking whenever I'm in stop and go traffic. So that's off, and then there's probably going to end up being a bunch of wires or things that we're going to have to take out here. Just kind of learning as I go. I've been trying to find a tutorial on this. We're going to end up having to pop this piece up as well. That just kind of pops out, and then you can kind of move that over to the side as best you can. Something like that, that should be fine. But anyways, and then I think there's a couple of screws you might be able to see there. It's pretty dark in here. I'm probably going to have to get a light or something. But we'll have to undo all of those to be able to remove this piece. Alright, so in the middle of taking off the center console here, and I have this knee board that I just removed because it looks like in order to be able to get this whole plastic piece off, we're going to need to remove the knee boards. And I believe in here you have something like 3 screws that you have to undo. Again, sorry about the darkness here, but there's one that's going to be way back in the corner. You might be able to see it on the other side here. Let me go to the other side so I can show you. So in total you have 3 screws here. We have this one on the bottom, and then you can see the 2 that are sitting there towards the back. We're going to need to remove these anyways because more than likely we are going to be taking off the console here just to be able to access some of the wires behind the stereo. But we'll need to go ahead and remove all of those. And then you end up just having to use a little bit of force to be able to pry the actual knee board off once those screws are undone. And then after that, we should be able to remove this piece. So to remove the center console piece, I actually lied. There are a couple of other things you need to do to remove it. Namely, there are some wires that connect your DC outlet as well as your USB and auxiliary ports in here. And some of these cables can actually be pretty difficult to get to. If you guys can see in here, I'm actually looking at the DC outlet in that plug, and that is very, very difficult to be able to remove. I've been trying to remove it for a few minutes now, but thinking about it, I don't actually need to be able to take this center console out completely. I can just run all of the wires that I need through here, and then I also have access to the actual little storage area to be able to drill holes so that way I can run my RCA cables. So I'm not even going to bother trying to remove the rest of these cables right now, since I can lift this up to be able to access the bottom of it. That's really all I need. So with that kind of removed, I think we should be able to also remove some of this plastic here to be able to pull that up, and that'll make running cables a little bit easier as well. Alright, so we've got that main piece of plastic removed there that sits underneath the strut bar and behind the seats. This is what we're going to actually use to probably mount our amplifier. My original plan was to keep this concealed, but this is the only logical place really to mount it. So I'm going to try and just use the screws. Hopefully those will be strong enough to actually mount it to this piece of plastic. We'll have to see. Alright, so the amp is now secure on there, and it seems like the screws are actually doing a pretty good job. This is held pretty tight on there. I'm not worried about it going anywhere. If over time somehow it does start to wear the plastic, I can always just go back and put a bolt in instead. But that should hold for now. So what we're going to do is we're going to go ahead and place the plastic piece back in the car loosely. This of course will vary depending on where you decide to install your amp. But you want to put the amp in approximately the position where it's supposed to go in the car. That way you know how long you need to cut any of the cables that you're running. I'm not going to tighten it down just yet because we want to be able to move this around a little bit just to be able to access certain things and be able to run the wires a little bit easier. But let's go ahead and put this back in the car. All right, and with our amp placed back in the car here, the first thing we are going to do is start running the power cables for this as well as an ignition source, and we'll install the RCA lines to be able to input it into the amp. That way we can begin to tune it. It's important that when running the cables, you make sure you choose the correct gauge wire. For my application, I've ended up using some 4-gauge stuff. This is supposed to be good for right around 80 amps. That's what I've calculated the amount of amperage I'm going to need for this. And you also want to make sure that you get a decent fuse or some sort of breaker. That way you can prevent any sort of electrical overload to the amp. To be able to figure out how much amperage you need, I'll go ahead and explain Ohm's law and a couple of formulas that you'll need to use to be able to determine the power that your amplifier is going to need. To find this, you can also read your manual. It's important that you do that as well to get an idea of what type of wire you need. Alright, so in order to determine the thickness of the wires that we need to use for wiring our speakers, we're going to need to do a little bit of math here, so bear with me. But sometimes you can find this information in your manual for the amplifier, but oftentimes you're just going to need to go and work it out. So there's a couple things that we need to know here. First off, we need to talk about how to find equivalent resistance when you're wiring multiple speakers together. So there's a couple of different ways that we can wire speakers. We can wire them in series, where we essentially take two components of the speaker or multiple speakers and we wire them in line with each other, basically forcing the current to travel through one path. Or we can have speakers wired in parallel, where we might have a common line that the speaker is attached to. So like in this case, we can see that the current can either go through the first speaker or it can go through the second speaker on the way back. So this is a case where the speakers are wired in parallel. And then for my subwoofer, I actually have a component speaker, which means there are two different parts to it. So it actually has 4 leads. I can actually wire them in series, and that's how I have mine configured, so that the current is forced to go through both sections of the speaker. That's the case where the speakers are wired in series. So depending on how they're wired, we have to calculate the equivalent resistance accordingly. Whenever they're wired in series like this, all we do is we add the resistances together. Fairly simple. So in the case of the subwoofer, since it's wired in series and both components are 2 ohms, 2 plus 2 would give us a total resistance of 4 for the subwoofer. Now let's go ahead and try and calculate what the resistance will be, the total resistance of the 2 speakers that are in parallel for both the left and right side of my car. So for parallel, it's a little bit more complicated. The total equation is 1 over the inverse, or the reciprocal of each of the different resistances. So in this case, we have 2 4-ohm speakers wired in parallel. So our equation reads 1 over 1/4 plus 1/4. And that ends up totaling out to 2. So the equivalent resistance of 2 of these speakers in parallel like this ends up coming out to 2. There's a simpler way to work this out. If you happen to have 2 speakers of the same resistance, you can just cut that resistance in half. So half of 4 is 2. If you happen to have 3 that are wired in parallel, you have to cut the resistances in thirds, and so on. That trick only works though if your speakers are the exact same resistance. Otherwise, you end up needing to use this formula. So now we know what our equivalent resistances are for each of the channels that we're using in our amplifier, so we can use this to try and determine how much current is going to end up passing through our wires. So we need to know how to find current based off of the power that we're using. When we're talking about current through wires and trying to find the thickness of the wire that we want to use, we need to consider our peak power, because that's going to be the most current that'll go through it, and that's what the wires have to be rated for. So power is normally written as voltage times current. But since Ohm's law says voltage is equal to current times resistance, we can rearrange this a little bit to get the equation for power in terms of current and resistance. So power also equals current squared times resistance. And since we know the resistances of, or the equivalent resistances of each of our channels, what's being applied to it, then we can try and work out how much current is going through it. So for our speakers, the combined peak power between the 2 speakers is 420 watts. So I've substituted that in for power, and we just worked out that our equivalent resistance is 2. So we put that in for resistance, and then when we work this equation out, we know that I squared should equal 210 once dividing 420 by 2, and then the square root of that comes out to about 4.5 amps. Now looking at the subwoofer, it can handle a peak power of 600 watts, so we plug that in, and our equivalent resistance of 4. This gives us 12.3 amps of peak current. So we know now what the total current capacity should be of each of the wires that we're using here on the different channels. They should probably be able to handle up to 15 amps. We could use the same wire for both channels, and then we'll just go ahead and guard band it a little bit by assuming that we might have some higher current spikes here. So we can get wires that are rated for 15 amps for the wires going from our channels. Now, we should try and figure out what the total current should be going through the power wire that goes to the amplifier. And the best way to estimate that is just to sum together all of the currents that would be going through each of our channels at our peak consumption. So, since we have two channels A and B here, that might be at 15 amps. We would say 15 plus 15 for those two channels. And then at peak, this other channel with the subwoofer may also be seeing 15 amps. So in total, our peak power consumption might be up to about 45 amps of current. So we can use that to try and determine what the thickness of the wire is that we need to use also for the power that goes to our amplifier. Now, it's always good, again, as I said, to try and overcompensate for this. So the wire I used, I think, was actually good for up to 60 amps. And then the wires that I used for each of my channels, I think, were good for like 16 or so. But that's how we work out current capacity. Now, the way you actually find the thickness of your wire from that is you can go online and you can just look up a AWG wire spec sheet, and that will tell you, depending on how much current you're using, what the thickness of the wire is based on if you're going to go for like a solid core or for like a stranded core, which I would recommend because strands are easier to work with in terms of soldering and things. So based on our current, you can go and use the chart for wires, and I'll leave a link in the description below for that, so that way you can figure out the wires that you need to use for your setup. While we're on this subject, we should also probably talk a little bit more on Ohm's law and how we're going to end up tuning our amplifier, because before we hook up speakers, we want to make sure that our amplifier is using the correct voltage levels to be able to meet our RMS requirements. So when tuning an amplifier, we want to look at our RMS power to try and determine what voltage level we should tune the amplifier to. Amplifiers nowadays are voltage driven, they're MOS based, the transistors in them are based on voltages. So we look back to our original equation for power, and instead of substituting out the V, we can substitute for I, V divided by R, and we get this equation. Power is equal to V squared divided by R. So now that we have that, we can go and try and figure out what the voltage should be for each of those channels. So revisiting the different channels here, the RMS power that we would see out of both of our speakers combined, as we saw earlier, was 75 watts. This should equal V squared divided by our resistance, which was 2. And then working this out, we get that the voltage on that channel, the RMS voltage, should be 12.3 volts. Now, looking at the subwoofer, our RMS value should be about 150 watts for the sub, and our resistance is about 4. And then working this equation out, we know that the voltage should be about 24.5 volts. So once again though, when I tuned my amplifier, I tuned these down a little bit, and you might also adjust this based on what you want to do. I went ahead and set the voltage for the speakers to, I think, like something like 10 volts. Just to make sure that it's not getting near the maximum RMS rating here. And plus I wasn't really, I kind of wanted to tune it more for the subwoofer instead of like the treble and like the tweeters and the woofers. So I went ahead and dropped that down to about 10 volts. And then for the subwoofer, I tuned it to right around 24 volts, which we worked out from this calculation, just slightly under the max. That way I had a little more on the bass side, and I still had a little bit of wiggle room there. That way it wasn't reaching the max rating on those speakers. So using this information, we can now go back and we can determine what the wire thickness is that we need and how to tune our amplifier properly. To run our cable, we are going to be going through the firewall on the passenger side. I have heard that in the manual transmission, it is easiest to go through a wiring loom that's going to be on this side. So we need to pull up all of these plastic pieces here to be able to access that. So we're going to go ahead and do that now. The power wire that I'm referring to here is the main positive wire for our amplifier. This is the one that's going to draw the most current and should be hooked up directly to the battery, using a fuse in line as well to prevent overload. This can be the trickiest part of the entire install because you have to find a way to get this wire through the firewall and into the cabin. Fortunately, underneath all the plastics here near the battery, there is a wiring loom that we can send the cable through fairly easily. Alright, so a bit of a status update here. I put a slit in the bottom of this little rubber piece really close to where the factory harness goes. You want to be really careful not to snip the wire, as you really don't want to damage something, otherwise trying to fix that can be really difficult. But just a small slit, and I was able to feed through my 4-gauge wire here. I'm not actually hooking it up to anything yet. I was just feeding it through to see if I could find it on the other side. And it may not come off on camera, but hopefully y'all can see that there. I have managed to locate the wire, so I have successfully drawn it through the firewall. If you are driving anything other than a 370Z, of course, where you route this is going to be different. You may end up having to actually drill a hole, but ideally what you want to do is try and find somewhere where some factory harnesses are already going through your firewall. That way you can run your cable into the cabin. So now that I know that I can feed that through, I'm actually going to pull my wire back out, and I'm going to start wrapping it in electrical tape to try and make it look more like some of the factory harnesses in here. And this will also give it a little bit of extra insulation to prevent it from shorting on the body. Alright guys, we finally got the cabling all wrapped up here in electrical tape. Again, this was to make it look like the factory OEM harness, as well as to add some extra protection for the cable. I have left one end with maybe about 5-6 inches of exposed just regular cable here. This is so that when we feed it through the plastic, we'll actually see that this is the positive terminal. So I've just left that red, and then I've got a little bit, if I can find the other end here, left a little bit here as well, because I will be cutting off this section of the cabling to be able to attach it to our fuse. But now we're going to go ahead and rerun it back through that location in the firewall, and we're going to try and lay the cabling approximately where it needs to go to be able to get back to the amplifier. While you're routing this wire, you want to look for opportunities to try and tuck it away places where it won't get in the way of the plastic panels when you reinstall them. I saw an opportunity to tuck it inside of these little clips here near the door sill, so I went ahead and did that just to try and keep it out of the way of things, and then routed the wire behind this main plastic panel that our amplifier is attached to. Alright, so we got all the wire run through here, and it is currently sitting behind the plastic here. Actually, I think you can see the end sticking over here. But we'll go ahead and pull that all the way around. And now what we're going to end up doing is we're going to drill a couple of holes through the plastic here to be able to feed that cabling through, so that way we can actually hook it up to our amp. You only want to drill a hole that's going to be large enough to be able to feed the cable through. You don't want to leave too much of a gap for dust and things to get in there. So we'll go ahead and drill that. We'll start hooking up the power leads to this, and then we can keep going. Alright, so quick update on the wiring. I finally have the positive lead attached here. It was too difficult trying to get this on there with the amp attached to the plastic, so I went ahead and unscrewed it. So that is now placed in there. This just uses a little hex bit to be able to thread in basically a screw that holds it in place. So we've got that attached. We have to do the negative terminal now. Here is how that is wired, by the way: the positive terminal, negative terminal, and then this is going to be an attachment for the ignition lead, which we'll get to in a second. So now, and of course, if you have a different amplifier, make sure you read the manual to figure out where this wiring is actually supposed to go for you. But next we're going to go ahead and do the negative terminal. For that, you can connect it to pretty much any piece of body that's made of metal. Behind this piece of plastic here, I'm thinking what I'm going to do is use this bolt right here. I think this is 10 millimeter. I'm going to just go ahead and attach my lead here, and we'll want to sand it down a little bit because it does have a bit of, I guess, overspray or paint on it. You want to make sure you get a good contact here to be able to run up to however many amps that your amplifier is going to be using. So I'll go ahead and try and attach to this. You can connect this ground wire to pretty much any metallic object in the car, but preferably we want to look for something that's on the body, and there's a bolt that you might be able to hook up a connector to. I used a ring connector for my bolt, and of course it is really important that you sand it down just to get off all the paint. That way it makes really good contact, otherwise your amplifier is going to have issues. Alright, so I'm on the passenger side now, and it might be difficult to see, but I was running the ignition line cable there between the positive and negative terminals, and I've got it coming out here now near the center console. And what I'm trying to do is basically find somewhere that only gives a 12 volt signal when the car turns on. What that basically means is the amplifier itself will not turn on and consume power unless the ignition is on. And what I found was I was looking for this DC outlet here, so you can see this yellow wire that connects to the DC port. I couldn't find a diagram for it online, but there's only a black and a yellow one leading to it, so I assume the yellow is probably the accessory on. And it turns out it is. I ended up using my voltmeter here, multimeter. You can pick one of these up for like $2 or $3 online. And I checked the voltage against just a bolt somewhere when the ignition was turned off, and it read nothing. And then when you turn accessory on, it reads 12 volts. So that's exactly what we want. We want to send that 12 volt signal to our amp whenever we are turning the key on. That way it is only on whenever the accessories is on, and it won't be consuming power when the car is off. So I just cut a slit there and tested it, and since that is the correct location, I'm going to go ahead and take off a section of the protective wiring here, and then I'm just going to solder in line the line that's leading from the amplifier to this wire, and then we should be good to go. It's going to be a little bit difficult to film that, so I'll just show you guys once I'm finished. Alright, so now I have our wire spliced into place. It is connected to the yellow wire, and then I rewrapped the wiring harnesses together using electrical tape. Unfortunately, I couldn't show this because it is pretty cramped in the space that I'm trying to work in to try and get a soldering iron and everything in here. But that completes the installation of the ignition switch cable, which again connects to the location there between the power and the negative terminal. This location, of course, may be different depending on your amplifier, but that means that our amplifier is now capable of receiving power. We're not going to test that yet because we also need to give it some sort of RC input before we can start testing it and tuning it. So this little section of the plastic right here underneath the 370 is going to stretch into the center console section here, where I am planning on sending my Bluetooth adapter with the RCA outs. So I'm going to drill a couple of holes here to get that left and right out through this console. Actually, I might only need to drill one for the jack because it's a jack to RCA. But I'll drill the hole, and that way we can run our input cables out, and we will be able to run RCA into our amplifier. So I drilled a hole just large enough for my auxiliary to dual RCA out cable to be able to run into the center console and hook up to the Bluetooth adapter that I have. For the two RCA inputs, I need to split it out into 4. That way I can actually hook it up to my 4-channel amp. So for the left side, I used a splitter and then connected both ends of that splitter to the left channels on the amp. And then of course for the right side I did the same thing. This way I could use all 4 channels on the amplifier. Once that was completed, I went ahead and installed the circuit breaker fuse in line with the positive terminal wire and then connected it to the battery terminal using a ring connector. One thing before we do turn it on, I actually did need to go ahead and hook up the positive lead here. So I have my 80 amp circuit breaker here, and that's currently set to the on position. It has not been tripped. And I've got it wiring in here through the side, which I went ahead and modified this terminal cover, as we saw, to be able to fit the cable. I would try to avoid having that much of a bend in your cable if you can, just to prevent fraying, but sometimes it's kind of unavoidable. Really the important thing is to try and keep it out of the way of the battery so that this is still accessible when you want to remove it. I've gone ahead and just mounted it to the side of this fuse box here with a piece of mounting tape, just as a sort of temporary solution until I can think of something better. It still leaves the lid of this accessible, so whenever I need to change a fuse under here, I can. And of course, you want to make sure you leave your fuse or your circuit breaker in an accessible area as well, in case you do actually trip it. But now that that's in the correct location, we can go ahead and reinstall our negative battery terminal, and we should be able to now test the amplifier, because the next thing that we're going to have to do is we're going to have to tune the amplifier, adjust the gain to where we want it. So we will be basically probing each of the different terminals that we're going to be using for our speaker inputs and making sure that the RMS voltage is set to the correct area based on the gain that, or the voltage and the power that we're looking to have. Alright, so I have the accessory on now, and I have paired successfully with the Bluetooth adapter, and now what we're going to be doing is tuning the amplifier to get the gain that we need before we actually hook any speakers up. Otherwise it's possible that we could damage the speakers, or we may not amplify it enough so we don't get the sound we're looking for. And to do that, I have downloaded a couple of sample files here. These are basically files that are used for tuning amps. One of them is listed as 50 Hertz, and then there should be another file located here called 1 kilohertz. So what I'm going to be doing is using the 50 Hertz signal to be able to tune the mono channel for my subwoofer. I'm going to be bridging 2 of the channels here to be able to power the sub, and I'm going to use that to tune that channel for the power that I'm looking for. and then I'm going to be using the 1 kilohertz channel or file to tune the other 2 channels to make sure that we're getting the gain that we need there. I'll explain this process in greater detail. So to explain how to tune this amplifier a little better, first what you're going to do is set the gain on both of the channels all the way down to the minimum. And then you're going to take your phone or your stereo or whatever it is you're using to play your test tone through your adapter. You're going to set the volume all the way up to high, max volume, and then you're going to play the tone depending on which speakers you're adjusting. For the subwoofer, again, I'll play the 50 hertz tone, and then for the speakers, I'll play the 1 kilohertz. So while you're playing that, no sound's going to come out because you have no speakers attached to it. But what you'll do is you'll go to the other side where all of the channel inputs are, and you'll put your multimeter set to AC voltage across the 2 leads for the speaker, and then you should be able to measure your RMS voltage. And then what you'll do is you'll slowly adjust the gain using the knobs on the side to match the RMS voltage levels that we calculated previously. All right, so we just got finished tuning up the amplifier and setting the gain correctly. I've currently got 9 volts on my 2 outputs for channel A, and then about 21 volts or so for channel B. That's actually set to the minimum gain possible. So that's all now tuned up and ready to go as far as the gain's concerned. I've gone ahead and unplugged the negative terminal. And one last thing we're going to do before we wire up the speakers is, at least for this amplifier, we actually have a bass booster controller, which is currently sitting somewhere in there. Actually, there it is. And we're going to try and find somewhere convenient to be able to store this thing around all the wires. Then we'll go ahead and get to the fun part, which would be installing the speakers. All right, so we have our bass booster already now wired into the amplifier, and I currently have it sitting inside of the center console, where it's difficult to see right now. But we are at the back of the car because we were getting ready to wire up the subwoofer. We're going to be wiring the 2 2-ohm coils in series with each other to make a 4-ohm load. That's how I have decided to configure this. So in order to wire this in series, we have the 2 different sides here, and we are going to wire 1 black to 1 red, and then we will just take these 2 and bring them out. That'll keep this component speaker in series, and then we'll go ahead and just run the lines through the center, and that should complete this one. Now, before we, of course, do all that, we are also going to have to try and widen up some of these holes, because I'm going to run the 10 gauge wire through 2 of the mounting holes, and then we'll use the other 4 locations to actually mount the subwoofer. So before we get into installing these speakers, I figured I would talk to you guys a little bit about how the speakers work and some of the considerations that you need to make when you're picking speakers out for your setup. So to start with, the speaker, the way it works is there's a diaphragm that is the kind of front face of the speaker, and below that in the middle is attached a magnet, and when current is applied to the speaker through a little solenoid, a little coil that wraps around it, it causes that magnet to want to deflect some amount. And when that deflects, it's going to push on the diaphragm and cause it to push outward or inward, and that causes air molecules to be moved around, producing sound. So knowing how this works kind of helps us in a couple of ways determine some of the things we need to consider. For instance, the brand or material that the diaphragm is made out of. Now, unfortunately, I can't speak to this that much because I'm not familiar with what the best brands are or what materials you want to be making your diaphragm out of. And of course, it's also going to vary depending on the type of sound you want and how the speaker is laid out. But you can always do some research online into what the best-selling brands are and some considerations to make when you're looking at materials. But some of the other things we want to consider, and probably the most important thing, is going to be the size or diameter of your speaker. If you're going to be replacing your door speakers, you want to make sure you get some speakers that are actually going to fit inside the factory mounting location. For the 370Z, I have some 6.5-inch speakers that I replaced with the Pioneer ones that I got. And my biggest consideration there, of course, was making sure that I found one that was about 6.5 inches. The size for your speakers may vary, of course, so you just want to kind of check to see what size speaker you need to find for your vehicle. And then you also need to consider, is the speaker you need round, just perfectly round, like a circle, or is it more oval in shape? Because some speakers aren't just perfect circles. You have some that are a bit elongated as well. The other thing you want to consider is the mounting depth. For the subwoofer that I have, I didn't have a whole lot of height in terms of the subwoofer box that I built, so I needed to find a shallow depth speaker that I could actually mount inside my box. The mounting depth is measured as the height from the point where you're actually going to mount the speaker all the way down to the base of it where the magnet is stored. So in the case of, for instance, door speakers, you may want to measure to see how tall the speakers are from the factory, because if you get a speaker that's going to mount a little bit deeper, that could cause issues in terms of the mechanisms that control the window may end up bump into it once you're trying to raise or lower your window. So that's just another consideration that you need to make. Also want to look into the frequency response. You want to make sure that you can get both to the high-end frequencies as well as the low-end frequencies so you're hitting the full range. And this can be a bit difficult and kind of challenging to try and get done correctly, depending on the setup in your vehicle. If you, for instance, maybe only have 4-door speakers, you don't have any tweeters or subwoofers installed in the car, you need to look for some speakers that have like a full range of frequencies to be able to try and hit that full range in your songs. So this can be done in a couple of different ways. You can look for instance, 2-way or 3-way speakers. Those are basically set up to where you have like a tweeter mounted in the middle of your woofer, and so the tweeter can hit those high-end notes while your woofer takes care of the low end of the spectrum. But if you have the flexibility to install tweeters as well as subs, you may look into component speakers where each of the individual components, such as the tweeter or the sub, are responsible for individual frequency ranges. So the other thing you want to consider with your speakers is how much power do you need out of them. And this is a common area where a lot of people can get carried away. They think, oh, I need 100-watt speakers in my doors to be able to get up to the level of sound that I want out of my car. To kind of give you an idea, if you're only needing to build this audio system for yourself, you're not trying to enter it into like a sound competition with other cars, or you're not trying to constantly show off how loud your music can get, you really don't need anything more than 35 watts for like your tweeters and your woofers. To give you an idea of how wattage corresponds to loudness of sound, 1 watt is like being in a loud restaurant or on like a bustling street with a bunch of traffic going by. 10 watts is equivalent to a motorcycle. 35 watts gets you up to a sporting event, and now we're already in the range where we're starting to risk like hearing loss. 150 watts is like being in a rock concert, and 400 watts is like having a trumpet just kind of blaring in your ear constantly. So you really, as I said, don't need anything more than about 35 watts for most of your speakers. Now, of course, hearing loss is also a function of frequency. Higher end frequencies at 35 watts are going to damage your ears more than lower ends typically. So for my subwoofer, I ended up going for something that was about 150 watts. But that's just something to kind of keep in mind. You really don't need something that is stupid loud in your car. And then, of course, the other thing you need to think about is cost. How much are you willing to spend on your speakers? For my woofers, I really wasn't looking to spend a whole lot of money. I spent about 40 bucks total on both my woofers, and my tweeters I think were about $20 a piece. Nothing too expensive. I'm not looking for the best sounding quality out of my speakers. I'm not an audiophile, but I did want to improve the factory sound a little bit, so that was kind of the budget I had set aside for those speakers. So now that we have some of the considerations that we need for choosing speakers, let's go ahead and get to installation. With component speakers such as this one that give you the option to either wire both cones in series or in parallel, the method that you choose really depends on the resistances of the 2 different components, as well as the tolerances of the amplifier itself. For this particular sub, it's 2 2-ohm loads, and the amplifier only supports bridging for down to 2 ohms, and it won't support 1 ohm loads. So I have to wire these in series just to be able to get the speakers to work correctly. Otherwise, I could risk overloading and destroying the amplifier. So that's why I've chosen to wire them in series here. Okay, and with that first wire installed connecting the 2 cones, we are now looking at our current resistance, and it looks like we hit 4 ohms. It's reading about 5, but that's mostly due to the resistance in the actual prongs here, trying to measure what we're looking at. But now that we have those currently hooked up, we're going to go ahead and drill the hole to be able to run the wires through, and then we are going to go ahead and run the wires over and into the cabin. When mounting subwoofers, I typically would recommend that you go ahead and use all 6 or however many screw mounting points that they provide. For this, I am using 2 of them to send my wires up out of the box because there isn't really a better way for me to do it because this entire box is surrounded by a spare tire. So I've got them going through 2 of the screw holes. This means that it's possible for air to maybe leak underneath where those screws normally would be, which would be sealing the subwoofer up. So if you have the ability to, I'd recommend you route your wires somewhere else. But for my particular application, I'm using these screw holes to send my wires up. For this particular amplifier, since I am bridging channels 3 and 4 for my subwoofer, I need to connect the negative terminal to the negative side of channel 3 and the positive terminal of the speaker to the positive side of channel 4. But again, this will all vary depending on your configuration, so just consult the manual for the amplifier to determine how to hook up your wires. Alright, so that is now the subwoofer all connected up. We're going to go ahead and reconnect the battery, and we're actually going to test the sub out now to see if there's anything else that we need to change. and then we'll move on to installing the woofers and the tweeters. Alright, so we just tested out the subwoofer, and the subwoofer is actually sounding really nice. I'm really enjoying the sound that's coming from this. I'm not actually going to show it on camera though, just because the microphone doesn't pick up the sound quite the same as it does in real life, so you really can't get a good comparison off this. But we are going to go ahead and move to doing the woofers and tweeters, starting with the woofers. And to get to these here, you're going to have to take the door panel off. Now to do that, there is going to be a little door right here and one down here that you're going to pop off using a trim removal tool, and then you'll have a couple of bolts in there that you'll remove. And then once that's done, I've heard that you can grab onto the door handle as well as onto the vent, and all you got to do is pull away from the actual door to remove the panel. And then the last thing you have to do to get the panel off is on the back of the door handle, there will be a couple of cables going into it. These typically just slide out of place for you to be able to remove. One other thing I forgot to mention about the door is you will also have a couple of wire connectors to attend to. They will be near the different controllers that are on the door. You'll just need to disconnect these two connectors, and then you should be able to take the door off. Now, after uninstalling the speaker, which required about 3 bolts to take off, and unplugging it, I ran into a serious issue trying to figure out how to run the wires through the door. Alright, I've spent probably the last 2 hours trying to figure out how to get these wires into the doors without having to just drill holes in the side of the fender here, or where the door meets the car, because I really wanted to try and keep these within the little weather protector, and the only way to do it is to go and drill through the OEM connector that you can see there and some of the unused pins to be able to run your wire. And this is a real pain in the ass, but I'm going to go ahead and detail this process when I do the passenger side, because it looks like we got a similar deal going on there. So I'm going to go ahead and get this speaker wired up, and then we'll go to the passenger side, and I'll show you guys step by step how to do this, because man, this took quite a lot of research and time to figure this out. I actually have made a separate video detailing this process for the 370Z. The link should be on the screen now. It took about 10 minutes in itself to explain because this process is just really complicated, so I figured I wouldn't bog this video down any further with that. But basically, just to give you a quick rundown, the problem lies in if you want to run your speaker wires through the doors like rubber hose, the protective hosing, and into the car, there's a Molex connector that's in the way, which prevents you from being able to do that. Most cars are probably going to be sort of the same way. So the problem is you need to find some unused pins to be able to drill through to run your wires. If that's not possible, I mean, you can always drill a hole through the side of your car as well, but that might leave a gap for water to get in, which is probably a no-no. So you want to try and run your wires through the factory hose if possible. That way you can kind of keep them weather protected. It can be a bit of a challenge though. So if you are trying to do this yourself, highly recommend watching my other video. Alright, so now that we have that door connector back in place, we're going to go ahead and install our woofer. Now, one thing you'll notice whenever you're installing this is Nissan used a pretty weird adapter here for the door. So any standard woofer is not really going to be able to have all the holes line up. You can only get 3 at best. But that's really all I'm looking for. Ideally you would put 4 in, but I'm just going to have 1 set at the bottom to hold the weight of the woofer, and then I'll just have 2 at the sides. Nissan only used 3 of them to begin with themselves, but it should be enough to hold the woofer in place, and I already checked this with the other side, and it really holds that woofer on really well. So that's what I'm going to go with now. Ideally though, you should use some sort of ring adapter. They do sell them online specifically for this sort of setup here with the screws. But you'll go ahead and set that on there. I'm going to drill holes in the plastic where my screws are supposed to go. And before I set the woofer in, of course, I'm going to also connect the 2 leads as well. Alright, now the woofer is nice and secure on the door. We've got our wires coming through now, so we are pretty much done with the install of this. The next and last part is to install the tweeter. So up here you have this kind of plastic cover that goes on top of the tweeter. All you need to do is get a trim removal tool in here to pop it up. Then there will be 4 screws, which are 8mm, that's holding the tweeter itself in. And once you do that, you should be able to pull the tweeter up and out, and there will be 1 plug that's holding it in as well. Then the tweeter will be free. So you're going to need to make some sort of adapter for the aftermarket tweeter. Some people I have seen have cut the diaphragm out of the actual speaker and then just sawed off these metal lines here to be able to use the actual plate, and then they just cut the diaphragm to the size of their tweeter. I'm going to just leave these intact. There is actually a really nice kit online that you can buy on Amazon. I'll leave a link in the description below. But it is basically like I think it's either plastic or it's a metal adapter that you then cut to the correct size for the tweeter that you need. I don't have this at the moment, so I'm going to use a pretty unsophisticated material here. I'm just going to be using cardboard, and I will be cutting up the adapter to the size of the stock tweeters here. I don't usually recommend this for a long-term solution because cardboard can rot over time, especially if it's exposed to like humidity. So I'm just going to use this as a temporary fix until I can get a proper adapter to install here. So I set about creating a cardboard adapter for my new tweeters. I used the stock one as a reference to get the shape correct and the locations of the mounting holes in the correct place as well. I cut out the hole to be able to fit my tweeter. Then I went about soldering some longer wires onto the tweeter itself so that I could actually feed it through into the footwells. So the way you reinstall it is you'll just feed your wire through the mounting location until you can find the wire on the bottom side and the footwell, and then you'll go ahead and mount your tweeter using the 4 screws that you took out to take out the OEM ones. And with both of those wires hanging down, I was able to solder them together in parallel along with the woofer wires. And then I used one of the larger gauge wires to connect both of those over to the amplifier. Alright, so the camera died, so I ended up having to recharge it, but I have already run all of the cabling from the passenger side around, and I've already hooked it up to the amplifier. Went ahead and turned the car on and tested the sound out. Sounding absolutely great. I'll maybe get a sound clip of it towards the end of the video, but again, really the sound from these does not come off on the microphone, especially the one that I have. But anyway, so this basically means that all the wiring and everything is done. That means all that we're left with is some cable management. I'm going to try and tidy all this up and actually get the amplifier fastened to the piece of trim here. Get all the wires tidied up, and then all that we really have left is to reinstall all of the panels in the car. I won't go into too much detail on all this. Basically, you're just going to be following the reverse steps to get all the door panels and everything put back on. So we'll go ahead and reinstall all the panels. So of course I set about tidying up the wires. The main thing is you want to try and just bunch them up to make sure that they're not just scattered everywhere and might be loose and just kind of flopping around in the car, because whenever the bass hits or whenever you're playing louder music, it could of course shake around and it'll cause a rattling noise, which is kind of unpleasant. So you just want to kind of tidy things up. You want to make sure that your wires are routed away from any of the connection points for your panels, so that way when you reinstall them they won't interfere. And yeah, that's pretty much it. Alright, and we are pretty much done here except for reinstalling the seats, but I've got all of the panels reinstalled in the car. I've gone ahead and paused here because I wanted to give you all the tip for the day, which is while your seats are out of the car, you might as well go ahead and vacuum underneath them because it's not often that you get access to this area. So go ahead and give that a quick cleanup. You might want to wipe down some of the panels as well while your seats are not in the car, and then reinstall the seats and you're good to go. And with that, the video is finally completed. I didn't intend for it to go this long. It's looking like it's going to be about an hour long now, based on the editing that I've done so far. So for those of you that have stuck it out and watched the entire thing, congratulations. I probably should have broken it up into multiple parts, but my goal with this video was to try and have one complete guide showing everybody how to upgrade their audio system. So that's kind of why I did it the way I did. I hope you guys found it informative. I hope somebody finds some use out of this video. So now I'm going to play you guys a song so you can hear what the sound system is like. Understand that it won't pick up as well on the camera's microphone, so it doesn't sound as good as it does in person. But from my experience so far in the month that I've had it, it sounds absolutely amazing. The 8-inch sub really kicks. It adds a really nice bit of bass to the whole sound system. The speakers that I installed also sound much better than the stock ones. The only problem is the tweeters have a bit of a crackle, so I'm still trying to work that out. But other than that, I'm really happy with the sound system, so I'll let you guys hear it as well. Thank you guys again for watching, and I'll see you all in the next video.